All right, so writing equations for parallel and perpendicular lines. Go ahead and write down this part. Just write down parallel, and then, of course, this piece here. That's all you need. You don't have to write all the words. So if I want two lines or two equations to have lines that are parallel, what has to be true about those equations? They can't touch, but I'm talking about the equations themselves. A different y-intercept and
different x-intercept?
Not necessarily. That doesn't have anything to do with this. But technically they should, yes. The same slope. Thank you, Robbie. Yes, same slope. So in this case, our slope is negative 1/4. That means the new slope also needs to be negative 1/4. I'm just using this little arrow to kind of show that. I also have an x and a y value. So that means I can actually use point slope form to help me help me create this equation. So I'm going to substitute what I know. So I have y minus 6 equals negative 1/4 times x plus 8. Again, I substitute the x, the y, and then the slope that we need. Now we have to get this equation to slope-intercept form, which we're going to do the entire time today. So I have to get rid of my parentheses first. And now I'm going to add 6. So y equals negative 1/4 x plus 4. So these two equations, when graphed, will create parallel lines. So let's actually see what that looks like. So we have y equals negative 1/4 x plus 5 for the first one, and then y equals plus 4. So you can see the two lines when they're graphed, they are parallel. They have different y-intercepts. There you go. What if they had the same y-intercept? What would be the case? What if? Yeah, exactly, Ty. They'd be overlapping. They'd be the same line, exactly the same line. So keep that in mind. If you ever come across something like that, it's the same equation, because then that means, like, for example, this would be a 5, so that means it would be the exact same equation, right? Because the y-intercepts would be the same, the slopes would be the same, everything would be the same. Okay? All right, let's try the next one. Again, writing just this piece down. All right. So we have an equation of y equals 2. What type of line is that going to create? Is it going to be horizontal or vertical? Horizontal, right? Horizontal. Yes? Y'all agree? Horizontal? So that means if I'm going to create a line that's parallel, it also needs to be y equals. Wouldn't you agree? Okay. So we know it's going to start off like this. If this second equation needs to pass through the point -3, 4, remember this is x and this is y, what does y have to be equal to in order for that equation to pass through that point? We already have y equals 2. Look at the point. What is the y value of that point? What is the y value of the point that the equation has to pass through? 4. So then what does y have to be equal to? 4. Good. Thank you, Eric. Yes, 4. So that means, and when I graph these two, they're going to be parallel lines, parallel horizontal lines. One would be y equals 4, and this one would be y equals 2. These are actually the most simple ones, but you just have to pay attention to whether it's horizontal or vertical and which value you're going to need. In this case, it would be the 4 because it's a y equals equation. All right, I want you to try this one on your own. What is the slope of this equation? Use that slope to find the parallel line. And of course, go all the way to slope-intercept form. All right, let's see what we got. So I have my x and my y. I'm going to substitute it where it belongs. So this would become y plus 1 equals 2 times x plus 4. So then I'm going to get rid of those parentheses. So 2x plus 8, subtracting 1. So y equals 2x plus 7. How many of you were able to get that? Uh-oh, not enough. Maybe I didn't give you enough time. I don't know, but nothing new here. So keep in mind, we did point slope here and then slope intercept here. Could we go to standard form? Sure, if we needed to. So there's a lot of different ways we can go about doing these things. All right, now let's switch gears. Let's go perpendicular. Go ahead and write this down and this. All right, here's the next one. Oh, I'm not going to graph it. There it is. So in this case, our slope is a negative 2/3. Opposite would be positive, and reciprocal would be 3/2. Again, I have x, I have y, so I can use those values to get me where I need to be. So we have y minus 3 equals 3 halves, or 3 over 2, times x plus 8. All right, y minus 3 equals 3 over 2x plus 12. There it is, y equals 3 over 2x plus 15. Slopes are opposite reciprocals. The y-intercepts in this case don't matter because they can intersect at the y-intercept. It doesn't matter. So in this case, the y-intercept isn't a big deal. It's only the slope that matters when we're talking about perpendicular lines. All right, for this next one, I'm going to ask you to try it on your own, but I'm going to kind of get you started. This equation is actually in standard form. You cannot get a slope directly from an equation in standard form. You must transform that into y equals mx plus b because it's the slope you need in order to rewrite that equation in perpendicular format. So that is your hint, your get started point. So I would like for you to see if you can find the slope and the equation that would create a perpendicular line for that particular equation and point. All right, let's see where we're at. So I rewrote my equation to y equals mx plus b format. So y equals negative 3x plus 5. So my slope is negative 3, and to make it perpendicular, I must have a slope of 1/3. So now I'm going to rewrite my equation. So y minus 3 equals 1/3 x plus 9. So now I'm going to rewrite. Now I'm going to add 3. So y equals 1/3 x plus 6. Did anybody get that far? Did anybody get that equation? Guys, as long as you pay attention to those slopes, you should be good. You check those slopes. That's the main focus here. Good. Some of you did. Awesome. I may have not given you enough time, but you've got to, it's about details. Nothing crazy here. Nothing super new. Just the slopes. All right. You have an assignment to take care of in Schoology. It's not very long. You're matching some equations to their, parallel or perpendicular partner, whatever you're asked for. Take your time, but be careful and use the time now to finish so that you are not stuck trying to scramble later. If you need help, I will be here to help you. Let me know.